Hi, my name is Bishesh, and today I'll be walking you through a CNN project that I've built to classify images from the CIFAR 10 dataset. This project demonstrates my understanding of deep learning, KRAS, and how to implement convolutional neural networks to solve image classification problems. First, let's talk about the CIFAR 10 dataset. It's a set of 60,000 color images, each 32 by 32 pixels, categorized into 10 classes such as airplanes, cars, and cats. Now, I used TensorFlow's built-in keras.dataset module to load the dataset, normalize the pixel values to improvise training efficiency, and then split the dataset into training and test cases. Next, I visualize the dataset like some of like first 25 images were visualized by me by the following code. Next comes the model creation part. This model consists of multiple convolutional layers followed by max pooling to reduce the dimensionality and finally fully collected layers. The key layers are conv2D layers with ReLU activation function, max pooling 2D layers to downsampling the feature maps, and dense layers to perform the classification. This model is designed to progressively learn spatial hierarchies from the images, reducing their dimensionality while preserving essential information. I compiled it using the Adam optimizer and sparse categorical cross-entropy loss function. Next, coming to the training the model part. Once the model was defined, I trained it for 10 epochs with a batch size of 64. The dataset was split. 20% of the training data used for validation to monitor overfitting. After each epoch, we can evaluate the performance on both training and validation sets to ensure the model generalizes well. Next, after training, I evaluated the model on the test set to see how well it performed on unseen data. We achieved an accuracy of 75.7% on the test set, which is a decent result for this dataset given the model complexity. Here is a graph to visualize the predictions for individual images. This function compares the true label with the model's prediction, displaying the result on the image. Now, in summary, this project demonstrates how to build, train, and evaluate a CNN model using Keras. Now, after training and testing, we test it on a sample test case, like for the first test image and printing the label and the prediction. Like for the first image, that is I equal to 0, I am printing the prediction. So, the actual label for this image was cat and the predicted by the model was also cat. So, it's a correct result. Next, further two images were also predicted using the model, and these two results are also true. The first one is labeled as deer and predicted also is deer. And the last one is labeled as frog, which is also correctly predicted as frog. Now we have seen how CNNs can classify images from CIFAR10 dataset, and this workflow can be extended to more complex datasets and models. Thank you for watching.